Welcome back to the deep dive. So today we're doing something a little different. I want you to mentally check the calendar for a second. It is February 19th, 2026.
The future is now, apparently.
It really is. Because yesterday, a press release dropped that feels like it was ripped straight out of a hard sci-fi novel.
Yeah.
But it's actually about one of the most grounded, visceral human experiences possible,
Yeah.
taking a sick child to the hospital.
Yeah, and usually when we talk about health tech or, AI in medicine, we're talking about back-end stuff.
Yeah.
Faster billing, coding, or maybe an algorithm that spots a tumor on an X-ray a little faster.
Right, the stuff that happens behind the curtain, the stuff that keeps the lights on, but doesn't necessarily change how I feel when I walk through the door.
Exactly. But this is front and center. This is a fascinating collision of worlds. You have the high concept tech generative AI, spatial computing, XR meeting, the very real, very emotional reality of pediatric care.
We are talking about the launch of what is being called the AI Native Children's Hospital. Now, I know what you're thinking. I can hear the listener rolling their eyes. Great, another AI buzzword. Is the hospital going to hallucinate my diagnosis? Is a robot going to hold my hand?
It's a valid concern given the hype cycle we've been living through.
But we need to unpack this, because the sources we're looking at today, specifically from Eon AI Ventures and Eon Reality, suggest this isn't just about efficiency. It's about solving two specifically heartbreaking problems: the trauma of getting an MRI and the terrifying danger of taking a medically complex child home.
And that distinction is critical. We aren't just talking about a hospital with faster Wi-Fi or a cute chatbot on the website. This represents a paradigm shift. The source material uses a term that honestly stopped me in my tracks: sentient architecture.
Which sounds incredibly cool and slightly ominous at the same time, like the building is watching you.
It does have a bit of a 2001 A Space Odyssey vibe, doesn't it? But the concept is actually very benevolent. It's about a hospital environment that is aware, one that responds to the patient. It's moving from a static building where things happen to you to an active environment that works with you.
So here is our roadmap for this deep dive. We're going to break this down into three big chunks. First, we need to look at the why, the absolute crisis in current pediatric care that makes this high-tech overhaul necessary. Second, the what, these generative worlds and AI mentors, and finally the how. Is this actually feasible, or is it just a concept card that will never leave the garage?
It is a dense topic, but if we connect it to the bigger picture, it's really about safety and competency. So let's dive in.
Let's start with the why, because I think to appreciate the solution, you have to understand just how high the stakes are right now. The source material highlights a statistic regarding MRIs that honestly floored me. We all know MRIs are loud and scary, right? Even for adults. I had one last year and I barely held it together.
Oh, absolutely. It's a claustrophobic nightmare. You're in a tube, it sounds like a jackhammer is going off next to your head, and you can't move a muscle.
Now imagine explaining that to a 3-year-old. I didn't realize how often we have to fully sedate kids just to get a scan.
It is a massive silent issue. The data shows that for children aged 5 or younger, the MRI-related sedation rate is 66.2%.
66.
That is 2 out of every 3 children.
2 out of 3. That is wildly high. And I think there is a misconception here, I certainly had it, that sedation is just taking a nap.
Yeah.
You give them a little syrup, they snooze, they wake up, everyone goes home happy.
Far from it. That is the dangerous misconception. Sedation is chemical restraint. It carries significant risks. The source material notes that up to 64.4% of these sedations involve adverse events.
64%. What counts as an adverse event?
It's a spectrum. It can range from minor issues like prolonged grogginess or vomiting, all the way to serious respiratory distress where the child stops breathing properly. And beyond the immediate physical risk, there is the long-term worry. The FDA issued a safety communication back in 2019 specifically regarding neurocognitive concerns with anesthesia in young children.
Right, because their brains are still developing. You don't want to be blasting them with heavy anesthetics if you don't have to.
Precisely. So you have a terrified kid, worried parents, and now you have to introduce a chemical agent that might hurt their developing brain just to get a picture of what's going on inside them. It's a terrible trade-off that doctors hate making.
And let's look at the hospital side of this for a second. I imagine sedating a toddler isn't exactly a quick in-and-out procedure.
It's a logistical bottleneck. From an operational standpoint, a sedation case turns a 30-minute scan into a massive ordeal. It consumes 2 to 4 hours of clinician and equipment time. You need an anesthesiologist, you need recovery nurses, you need monitoring equipment.
So if a hospital is running, say, 750 MRIs a month,
the resource strain is astronomical. You're talking about thousands of hours of highly skilled labor tied up just keeping kids asleep rather than treating patients. It creates wait lists, it burns out staff, and it costs a fortune.
Okay, so that's the crisis inside the hospital walls. The sedation trap, let's
Yeah.
call it. But the sources highlight a second crisis that happens the moment you walk out the sliding glass doors, the post-discharge gap.
This is often the silent crisis. It's what happens when the hospital says you're good to go, but the parents, they don't feel good to go.
Especially if we're talking about a medically complex child.
Right. We aren't talking about a broken arm here. We're talking about a child going home with a tracheostomy, a central line for feeding, or a complex medication regimen with very specific dosages. When they leave the hospital, the parents effectively become the nurses.
I can't even imagine the pressure. You're not a doctor, you're an accountant or a teacher, and suddenly you have to keep this tiny human alive with equipment you barely understand.
And the statistics reflect that pressure. Preventable readmission rates for these medically complex children sit between 30% and 79%.
Up to 79%. That is staggering.
Yeah.
That means almost 8 out of 10 of these kids end up bouncing right back into the hospital.
Correct. And the key word there is preventable. The source states that the vast majority of these readmissions aren't because the disease got worse, it's because of failures in home care, an infection in the line because it wasn't cleaned right, a missed medication dose, a tube inserted at the wrong angle.
Which brings us to the training. If the stakes are life and death, the training for these parents must be incredible, right? Like a boot camp.
You would hope so, but currently, it's usually a stack of papers and a rushed conversation with a nurse who is already working a double shift.
Here's a pamphlet. Good luck.
Basically, it's what we call static tools. A piece of paper cannot answer your question at 3:00 a.m. It cannot see that you're holding the tube at the wrong angle. It cannot correct you.
So you have the trauma of the MRI on one end and the panic of home care on the other. This is the landscape Eon AI Ventures is stepping into. Let's pivot to the solution, the AI native concept.
All right.
Let's start with the MRI problem. Eon N's proposing something called Generative Worlds. Now, I'm a bit skeptical of the metaverse hype. How is this different from just giving a kid a VR headset with a cartoon on it?
That's the key difference. This isn't distraction, it's preparation. The concept relies on generative AI to create fully interactive, high-fidelity 3D environments. And the claim is they can generate these in under 10 minutes.
Okay, explain that 10 minutes part. Why does that matter?
In the old days of VR, and by old days I mean 3 years ago, building a virtual replica of an MR room would take a team of developers weeks. They'd have to code every texture, every light source. It was expensive and slow. With generative AI, the hospital can essentially say, create a digital twin of room 304 based on these schematics. And the AI builds it.
So it's scalable. They can do this for every room in the hospital without hiring a massive dev team.
Exactly. But the magic happens with the patient. Imagine a child, let's call him Leo. Leo needs an MRI. Instead of walking into that cold, sterile, noisy room for the first time on the day of the procedure, he enters a virtual replica beforehand. Dress rehearsal.
Yes.
A practice session. But it's gamified. Leo puts on a headset or maybe enters an immersive room, and he's in the MRI room. He can look around. But here's the crucial part. He can hear the noise.
That banging sound, that's usually the scariest part.
Right. But in the simulation, he's in control. Maybe he can turn the noise up and down. Maybe the MRI machine turns into a spaceship. He can play through the experience. He learns that the noise means the spaceship is taking off, not that he's in danger.
It's exposure therapy, essentially.
It is. The goal is very tangible. By familiarizing the child with the environment, you reduce the anxiety to the point where sedation isn't necessary. The source notes this shifts the dynamic from a medical procedure that happens to the child to an interactive engagement the child participates in.
That is a huge psychological shift.
Yeah.
If you can cut that 66% sedation rate down, you're saving brains, you're saving money. And honestly, you're saving parents from having to watch their kid go under anesthesia, which is terrifying in itself.
Absolutely. It reclaims that 2 to 4 hours of lost time we talked about earlier. It turns a bottleneck into a flow.
But let's look at the second solution, because this one feels even more futuristic to me. The Adaptive AI Mentor. This addresses the discharge problem. The parents becoming nurses.
This is where the technology gets really sophisticated.
Now, when I hear AI Mentor, I assume it's a chatbot on an iPad. I ask it, how do I clean the tube? And it prints out text. But the source material is pretty adamant that this is different.
It is much more than a chatbot. These are designed to be adaptive and spatial.
Break that down for us.
Adaptive means the AI isn't just spitting out a generic how-to guide. It adapts to the child's and the parent's age, emotional state, and clinical situation. If you are a calm, experienced parent, it might give you the quick version. If you are visibly shaking and panicking, it changes its tone. It simplifies. It reassures.
Wait, it knows if I'm panicking.
That's the sentient part we'll get to. But yes, through voice stress analysis or biometric data, it can gauge your state. It knows when you are overwhelmed.
Okay, and the spatial part.
This is the game changer. Think about that parent managing a tracheostomy at home. A chatbot on a screen is 2D, but the patient, your child, is 3D. An adaptive AI mentor using spatial computing, think augmented reality glasses or projection, can overlay instructions onto the real world.
So it draws an arrow on the actual tube.
Exactly. It can highlight the exact spot you need to clean, and crucially, it provides real-time corrective feedback.
That's the pocket clinician concept.
Yes. Imagine the AI says, insert the catheter now. You start to do it, but your angle is off. The AI sees this through the camera and says, stop, adjust your angle to the left. Okay, proceed.
That is wild. It's closing that gap between I read the instructions and I'm actually doing it right.
It ensures skill retention. And remember that 79% preventable readmission statistic. This is the weapon against that. If a parent is about to make a mistake that would send their kid back to the ER, the AI catches it before it happens.
It really emphasizes that point about static versus active tools. A pamphlet is static. Doesn't care if you mess up. This AI mentor is active. It's watching. It's like having the expert nurse standing over your shoulder at 3 a.m.
And that brings us to the environment itself, because for this to work, the hospital can't just be concrete and drywall anymore.
This is the sentient architecture,
Right.
which, again, I'm going to need you to demystify.
Yeah.
Because it sounds like the walls are going to start talking to me.
In a way, they do. This is the third pillar of the EON AI Ventures proposal. Sentient architecture means the hospital space itself is augmented by intelligent systems.
Give me a concrete example. I walk into a patient room. What happens?
Well, the source mentions adaptability to language and emotional states. Imagine a waiting room or a patient room that senses a child is crying or in distress. The environment could automatically adapt, dimming the harsh fluorescent lights, projecting calming visuals on the walls, playing soothing sounds.
Without a nurse having to run over and hit a switch.
Right. It's autonomous. Or think about the language barrier. Let's say the grandparents are there and they don't speak English. Usually you have to wait for a translator or use a phone app, passing it back and forth.
Which adds friction and anxiety to an already stressful moment.
Exactly. With sentient architecture, the room itself could display the doctor's explanation on the wall in the grandparent's native language, in real time as the doctor speaks. It creates a responsive environment.
It's interesting because usually hospitals are the most rigid places on earth. You have to adapt to them. You have to be quiet. You have to wait. You have to understand their jargon. This flips it. The hospital adapts to you.
And that's the clinical utility of spatial computing the source discusses. It's not just using AR or VR for a video game to distract a kid while you stick them with a needle. It's using those tools to create an environment that actively lowers cortisol levels, improves understanding, and makes the clinical team's job easier.
It all sounds incredible, honestly. But I'm going to play the skeptic again. I have to ask, is this real, or is this just a beautiful slide deck from a startup looking for VC money? We are looking at a press release from February 2026. Can we actually drive this car?
That is the inevitable question. And the source material addresses feasibility directly. They claim this isn't a 10-year plan. They cite an 8 to 12-week implementation period.
2 to 3 months to overhaul a hospital. That seems suspiciously fast.
It does, until you realize what they are actually installing. They aren't tearing down the physical walls. They aren't rewiring the plumbing. This is a phased approach focused on software and overlay hardware.
Okay, so they start small.
They start with the high-impact areas. The MRI prep rooms, setting up those generative worlds, requires a headset and the software, not a construction crew. And the post-discharge education modules, that's digital distribution to the parents' devices or rented headsets.
That makes more sense. You layer the intelligence on top of the existing infrastructure.
Correct. And we should mention the companies behind this. EON AI Ventures and EON Reality. They make a point to highlight that they have 25 years of experience in XR and immersive learning. They aren't a pop-up AI shop that started last week.
And they make a specific point about generic AI versus their AI. They say generic AI gives you 80% quality.
Yes, and that is a crucial distinction in healthcare. You can accept 80% accuracy if you're asking ChatGPT to write a limerick or summarize an email. If it gets a word wrong, no one dies.
But if an AI mentor tells a parent to inject 10 milliliters instead of 1 milliliter,
Exactly. You cannot accept 80% accuracy when you are dealing with pediatric safety. They claim their system is built for precision, aiming for that 100% quality required for high-stakes operations. They use what we call spatial AI, which is grounded in the physical reality of the medical equipment, not just language patterns.
that's comforting. Because hallucinations in AI are funny on Twitter, but tragic in a hospital.
Precisely. And regarding scalability, the expert context here suggests that because this is largely software and spatial computing hardware, it allows health systems to rapidly scale up.
Yeah.
Once the digital assets, the generative worlds, the AI models are built, deploying them to 50 rooms isn't much harder than deploying them to 5.
And it allows them to reclaim caregiver time, too. If the AI is handling the prep work for the MRI or the detailed training for the parents, the nurses and doctors can focus on the actual medical treatment.
It improves operational efficiency, which goes back to that resource strain we mentioned at the start. It's not just better for the kid, it's better for the hospital's bottom line, which, let's be honest, is the only way these things actually get adopted.
Cynical, but true. Money talks, even in medicine. So, let's wrap this up. We've looked at the nightmare of sedation and readmission. We've looked at the practice sessions and the AI mentors. If you had to summarize the promise here, what is it?
The promise is a hospital that learns, adapts, and speaks to you. It's about drastically reducing the trauma of care and the risk of going home. But if I connect the dots one last time, the so what here is really about redefining safety.
How so?
For decades, safety in hospitals has been defensive. We have rails on beds so you don't fall out. We have double checks on meds so we don't poison you. It's about preventing accidents. This model moves safety into the offensive.
Offensive safety. I like that.
It's active. It prepares the child so the panic never happens. It trains the parent so the readmission never happens. It's a shift from static healthcare waiting for things to go wrong to immersive healthcare preparing for things to go right.
That is a powerful way to frame it. It's not just fixing the broken leg, it's fixing the experience of having a broken leg.
Precisely.
Before we sign off, I want to leave you, the listener, with a thought. We talked about Sentient Architecture, a hospital that adapts to your emotions to keep you safe. If we can do that for a children's hospital, what happens when we apply that to our schools?
That is a provocative thought.
Imagine a classroom that senses when the students are confused and changes the lesson plan on the wall in real time. Or an office that knows when you're stressed and adjusts the lighting or the background noise. If the AI native model works for the most high-stakes environment possible, pediatric care. Is it the future of all our physical infrastructure?
It certainly suggests that our buildings are about to become a lot more active participants in our lives, whether we want them to or not.
Something to mull over. We'll be watching this roll out closely. Thanks for listening to this deep dive into the AI native children's hospital.
Thank you.
See you next time.